Our best bet is to listen for radio signals, like the SETI project. Interstellar distances are too large for us to travel to more than the closest stars if we want to explore the galaxy. So we'd better send robots, but we may not live long enough to hear back from them.
If we find life on another planet, we're going to, first of all, know that we're not the center of the universe anymore.
I think it's important that we understand our place in the universe. I think it's terribly important that in so doing, we come full circle to respect the world that we're on and to understand the distances and what the universe is all about.
We will know that if the conditions for life are present, then life can arise at multiple sites in the universe, and that we now live in a living universe that we're ready to explore.
I think the revolution that science is giving us as we look at our solar system in the accessible universe will continue to unfold. When we get the next generation telescopes up there, we will not only see indirect evidence of other Earths, but we'll see the earlier time of the universe and have better abilities to understand how the universe, the galaxies that populate it came to be. You have seen nothing yet, because it's only going to get better. And that zone, that gap between science fiction and science fact is just going to come together. And, you know, I've never met a science fact that couldn't be seen as interesting as some of the best of science fiction. And I think we're going to see that zone blurring together as we continue the quest for life.
Thomas Huxley, the great biologist in the last century, said that perhaps one of the noblest achievements of science and philosophy is to discover our true role in the universe. Who are we? Where do we fit in the larger scheme of things? That, he thought, was the central question unifying philosophy, science, and art. And today, I think we may be able to answer that question, because we are on the verge of perhaps the greatest breakthrough in the history of science, and that is the discovery of other life forms in space.
The expedition to Darwin 4 is an imaginary one. But the boundaries between science fiction and science fact continue to blur. As the gap narrows, the potential discovery of alien life forms holds mysteries as yet unknown.
Imagine a world where you can lift weights of up to 400 tons. Imagine a world where the lakes are made of liquid natural gas. Imagine a world where a single volcano is larger than all of the Earth's volcanoes combined. Imagine the moons of our solar system. Once, we thought the 9 planets were the ultimate destinations. But when we actually went to visit them, we couldn't help but become captivated by what lay beyond: the moons. 95 different worlds now known to hold the most exotic real estate in the solar system. Moons where geysers shoot as high as Mount Everest, where a single cliff is 8 times deeper than the Grand Canyon. And all you need to do to fly is flap your arms. Moons where you can explore the first water ocean ever found off planet Earth. We can explore and even search for life on the moons. Maybe the best place to look for life in the 95 worlds of our solar system. Neptune, a ball of gas 60 times larger than Earth. Like the other gas planets, there is no surface on Neptune to even land on. If we want a planet to explore, we'll need to look to the moons. Here, nearly 5 billion kilometers away from Earth, is the coldest moon ever recorded. At almost minus 240 degrees Celsius, it approaches absolute zero, the temperature at which all movement stops. If any moon should be a frozen ball of ice, it is this one. Yet instead, it is a world in full motion, dynamic and active. Welcome to Triton. The frozen surface is alive with geysers and volcanoes.
It has one of the most dramatic displays of volcanic terrains in the solar system, which sounds surprising perhaps because iceball, volcanism, they don't seem to go together. But in fact, Triton's form of volcanism involves molten ices.
Here on Triton are the first ice volcanoes ever found. The volcanoes start deep underground, where Triton's weak internal heat turns ice into liquid. Less dense, the liquid rises to the surface, creating an explosive eruption that showers the moon, not with melted earth, but with melted ice. The cold, slushy lava forms an incredible ice-sculpted landscape. Even more surreal than volcanoes made of ice are Triton's powerful geysers. On Earth, geysers are made of boiling water. On Triton, geysers are made of boiling nitrogen. As bizarre as it seems, with nitrogen you can boil water at minus 200 degrees Celsius. So cold, everything familiar to us would shatter like glass. And yet, so volatile it can produce the highest known geysers in the solar system.
Standing on Triton, we would want a pressurized and heated spacesuit given the conditions there. If you were dumb enough to go out of your spacecraft on Triton without a spacesuit, your head would explode in about 3 seconds flat, and then you'd freeze to 390 degrees below zero. Your body would be hard as steel. Standing on the surface, we would experience 1/12 of Earth's surface gravity, so we would feel very light and buoyant. We'd be able to jump 12 times higher, for instance, than we could on Earth.
And for the truly brave, a new sport, geyser diving.
It might be very interesting to go down into the holes if you dare. There'd be all sorts of reverberations with the supersonic gas rushing out. We may end up in a pool of liquid nitrogen, boiling fervently.
As nitrogen boils, it produces a vapor that expands hundreds, even thousands of times in volume. Intense pressure builds until the geyser finally gives. The explosive force shoots 10 times faster than any geyser on Earth. When it reaches 8 kilometers high, about the height of Mount Everest, the geyser darkened by carbon is sheared at a right angle by Triton's high-altitude winds, giving it the appearance of smokestacks scattered across its surface. Once, scientists assumed the outer moons would be cold and dead. Now we know that even 5 billion kilometers from the Sun, in the shadow of Neptune, a startlingly beautiful world in motion exists. And if the coldest moon can be this active, just imagine what the other moons have to offer. Orbiting Jupiter is the hottest moon in the solar system. Scientists once thought there could be little warmth 750 million kilometers from the sun. But here, the gravity of Jupiter and its other inner moons squeeze, bend, and twist this world until it heats up like a furnace. This is a world of erupting molten rock and poison gas plumes. This is a world so hot it is melting before our eyes. This is Io.
The surface of Io is an extraordinarily inhospitable place. To an unprotected human on the surface, the first problem would be the lack of a breathable atmosphere. And there's always the danger of being caught in a massive volcanic eruption.
On Io, there are around 300 active volcanoes. The main one, Io's Old Faithful, is Prometheus, a constant plume that sends a tower of poisonous gases 80 kilometers into the atmosphere. There's Loki, the largest volcano in the solar system. Scientists still don't understand its structure, but it generates more heat than all the volcanoes on Earth combined. And Amirani, 500 kilometers of oozing lava, the longest active lava flow in the solar system. Io produces 45,000 tons of lava a second, enough to pave all of the Earth's continents every year. It is hot, fast-flowing lava.
Lava on Io would flow like olive oil, and you couldn't outrun it. You could possibly ride a bike and get away from it on a bicycle if you could ride fast enough.
And if you had a mountain bike, it would be a treacherous ride, as Io has mountains twice as high as Mount Everest. Warm clothing would be essential, because away from the volcanoes, the temperature on Io is less than minus 120 degrees Celsius. Ride your bike near a searing lava flow, and you'd be burned on one side and frozen on the other. And where the hot lava hits the snow-covered ground, a magnificent plume shoots up to 400 kilometers into the frigid darkness of space. When the plume cools, it returns to the surface in a sulfur snow. Like a kaleidoscope, the sulfur changes color with temperature and impurities.
Io is covered in red and brown and yellow and even green. It must be quite extraordinarily beautiful.
On the molten world of Io, scientists would be keen to study the lava, how it erupts, and how it cools. And that is what these volcanologists are doing at the Kilauea volcano in Hawaii. They are recording the temperature of the lava flow.
About 2100 degrees Fahrenheit. That's a typical temperature here in Hawaii, but on Io we expect lavas to be about 500 degrees hotter, and that's something we haven't seen on the Earth for billions of years.
Io has the hottest lava in the solar system, over 1400 degrees Celsius. The last time temperatures came as close to this on Earth was 3 billion years ago.
So Io is a chance to go back and look at the types of lava flows that have been dead from the Earth. So it's like Jurassic Park for volcanologists.
To visit Io would involve immense risks, and not just from the volcanoes. Here, Jupiter showers the planet with radiation 4,000 times the lethal dose. But scientists may have found a safe haven underground.
The main obstacle to successful inhabitation of Io by humans is overcoming the high radiation environment. And probably the best thing to do would be to seek refuge underground, perhaps in something like this, a lava tube.
Io may be threaded with empty lava tubes, basically old plumbing from its dormant volcanoes. And the rock above would act as a radiation shield. Keeping exposure to a minimum, inhabitants could emerge from the lava tubes for brief excursions and be able to view one of the most magnificent light shows in the solar system.
If I could be standing by a lava flow on Io and looking up at the sky, what I would see would be glowing volcanic gases, very much like the northern lights on Earth. It would be truly spectacular.
The aurora is created when sulfur dioxide gas ejected from the volcanoes strikes charged particles emitted from Jupiter. Gas hitting electricity forms a gigantic neon light. The 95 moons give new meaning to the term extreme sports. It could be said the pioneer was Alan Shepard, who in 1971 landed in the ultimate of sand traps. With a one-handed swing, he drove a golf ball almost 180 meters.
Miles and miles and miles.
Of course, a professional golfer could have sent the ball over a kilometer. Now, the only limit to lunar sports is our imagination. Imagine snowboarding on Saturn's Enceladus, where ice volcanoes create the best powder snow in the solar system, and the slopes offer an unforgettable view of Saturn's rings. Imagine jet skiing on Saturn's Titan. No need to bring fuel, because the lake is made of liquid natural gas. Of course, if there was oxygen, there'd be no smoking allowed. The lake could go up in flames. On Uranus's Miranda, imagine abseiling down a cliff nearly 13 kilometers high, 8 times the depth of the Grand Canyon. If the rope broke, you wouldn't hit the ground for a full 9 minutes. Or imagine scuba diving on Jupiter's Europa, in the first water ocean found off planet Earth. Keep your eyes open for alien creatures. After all, it was in an ocean where the only life we know began. Lunar sports may seem like science fiction, but there are already plans to visit a moon called Phobos. When we head to Mars, it's likely we will visit one of its 2 moons, tiny Deimos, or a slightly larger speck of a moon called Phobos. Its size and low gravity make landing here cheaper, safer, and easier than on the Red Planet. This rock, the size of a city, looking more like a potato than a sphere, may be our next space residence.
Phobos is one of the smallest moons, and a real lightweight. The surface gravity there is less than 1,000th of what it is on Earth. And that means a human being on Phobos would weigh about as much as a mouse does on Earth.
less than 1/10 of a kilogram. We wouldn't walk on the surface, we'd float. But you need to be careful. There's a layer of fine dust 1 meter deep. Kick it up by mistake, and you wouldn't be able to see a thing.
Phobos is a very dirty place. The soil there is very dark. It's as dark as charcoal. This soil is created as meteorites bombard Phobos over the years and fragment the surface rocks into this powder and rocky soil. If we're not careful when we go there, we may stir up this stuff, and it's going to make a mess of everything.
Drifting over small, sharp craters, the shadows change rapidly as the sun rises and sets every 8 hours. With darkness, you'd feel the temperature drop 120 degrees to a bone-chilling 110 degrees below zero.
Because of the really low gravity on Phobos, you could have some pretty extreme sports. Even a pretty average pitcher, without trying too hard, could take a ball and throw it completely into orbit around Phobos. After about 20 minutes, after completing a whole orbit, the ball might come back at you from the other side of the moon. Baseball would be really interesting.
And not just baseball. Imagine the Phobos Olympics. The champion weightlifter here could hoist over 400,000 kilograms, the weight of a fully loaded jumbo jet. A gymnast could complete 3,000 somersaults before hitting the ground 25 minutes later. And a high jumper could go over 1 kilometer into space. The gold medal winner here would fly off Phobos and into orbit. Besides the games, there's tourism. Visitors would flock to the giant Stickney crater, 11 kilometers wide. A crater this scale on Earth would be larger than the United States. This gaping hole that is Arizona's Meteor crater pales in comparison.
This is an immense crater on Phobos. Standing there must be an impressive sight. It's 7 miles wide. I'm not even sure your eye could really take in the vista itself. It was blasted out of the west side of Phobos when a small asteroid, maybe twice as large as a football field, slammed into Phobos at about 14,000 miles an hour. Phobos is a feisty little survivor. Had the impactor been just a little larger, Phobos wouldn't be there.
The impact would have shattered the moon. Instead, the collision started a tremendous shockwave that stirred the inside like a blender.
A huge shockwave blasted through the small moon in about 10 seconds, completely rubbleized the interior of the moon. So even if Phobos been a solid piece of rock before the impact, it was completely rubbleized afterwards. It created a lot of void space and a lot of cracks and blocks inside of Phobos. And today those may be manifested as small, if you would, caves inside of Phobos.
Studded with caves, Phobos offers another extreme sport, spelunking, the exploration of caves. These caves would be natural homes, protecting visitors from meteor storms and deadly cosmic rays. Emerging from our abode, Mars would be clearly visible, looming in the sky a mere 6,400 kilometers away, no further than New York is from London. Phobos could be considered as a space station orbiting Mars. You could take quick trips to the red planet, but return to the security of a protected home away from Martian dust storms. In our lifetime, we may see humans gazing at Mars from that tiny moon called Phobos. There is one thing that all moons have in common: craters. From our own pockmarked moon to Jupiter's Callisto, the most battered body in the solar system. With most having no atmosphere to protect them, our 95 moons are the solar system's shooting gallery. Here at NASA, they're recreating craters with this giant cannon, 6 meters long.
This gun is the only gun like this in the world. It's one of the fastest guns in the West. This gun can fire something that will go almost 20 times the speed of sound, almost 4 miles per second, if you can imagine that. This little projectile is what we're going to be firing, and it really packs a wallop. When this thing hits, there's nothing left. And that's basically what we're going to try to simulate, making believe it's a mini asteroid that's going to be colliding with the moon.
Peter Schultz's work captures the birth of a crater. He can change the angle of the cannon, and he can fire at different materials. Today, he's taking a low-angle shot to try to decipher a series of strange craters on Mars. He'll fire at a metal block.
On Mars, we find these oblong craters. They're so oblong that they must have been formed by an exceedingly low angle. Very likely, these are indicating that they decayed out of an orbit, and this is simply a record of lost moons that have collided on Mars.
Schultz believes these low-angled craters are basically skid marks created by the demise of some 200 moons that slipped out of the orbit of Mars. Mars is a moon destroyer. Better get to Phobos soon, because it's doomed. In the next 40 million years, this tiny moon will join the 200 others and come crashing into the surface. Schultz is now trying to recreate a giant crater on our moon using a small glass sphere. He tries a variety of angles. Only one, a glancing angle, creates the crater without destroying the sphere. This fracture is remarkably similar to South Pole Icon, the largest impact crater in the solar system, so big that it covers 15% of the surface of the moon. If the angle had been only a few degrees different, our moon would not exist.
All the moons probably are lucky survivors from that last big impact. When you look at each one of these moons, you see these big impact basins that occur on them. If they had been a little bit bigger, or if they'd taken a more direct hit, they would have been blasted to smithereens.
Once we had hundreds, perhaps even thousands of moons in our solar system. Our 95 worlds are the lucky survivors. The 400,000-kilometer journey to our moon took 3 days using relatively primitive technology, computers with less power than today's pocket calculators. But in a brief burst of exploration, we proved that we have the ability to visit another world. Apollo 17 astronaut Gene Cernan.
You get down and then all of a sudden you get close and your engine starts stirring up all this dust. Perhaps the most quiet moment in my entire life, when all of a sudden all the dynamics stopped. And we landed on a surface moon and looked out there, and there was silence and stillness, and we were on another world. We were now seeing what has never been seen by a human being since the beginning of time.
As I step off at the surface at Taurus Littrow.
Cernan is one of only 12 humans ever to walk on another world. What he found was a stark, alien landscape.
Realizing they're standing in sunlight, surrounded by the blackest black that man can conceive in his mind, and there is the Earth, sitting in the middle of that blackness. Now that's a paradox on Earth, surrounded in sunlight, surrounded by blackness.
Man, I tell you, Falcon 109.
With only 1/6 gravity, the astronauts struggled.
That's what you call getting down into your work. Now that I got it.
Jack Schmidt having a few problems.
Dead coming.
until they discovered a new way to get around.
Somehow our computer tells you that to get from one place to another,